This tutorial will illustrate the cutting and pasting of a sequence of residues into a protein. There's basically two menu items here in HyperChem that are relevant to this kind of process. The mutate is simple and takes a single residue and replaces it by one new residue. This is quite simple and easy to use. However, it doesn't give you the generic operation of taking an arbitrary sequence of arbitrary length and replacing it by a different sequence with different length and/or composition. So that's the replace operation which we're going to illustrate. To do a replace operation, we first of all need the source sequence of residues, and we prepare those in advance. So we go up and let's choose a small sequence. Let's use an alpha helix and do 1, 2, 3, 4. Say a small sequence to be the source sequence. We select that and store that away in the clipboard. Then we bring in the protein. In this case, we'll use a simple Crambin, our old friend Crambin, and we have to choose a sequence in here to replace. Now let's choose. We're selecting residues, so let's select this one, 18, 19, 20, say, and replace those three by the new sequence. So we go up and we just say replace. It shows us the old sequence and the new one. We can align these a little bit better if you like, try to get them in the middle there. We can rotate this to try and align these. I don't know, that's not quite clear whether we're going to align these terribly well, but anyway, let's go and just do the replace operation. So now we have, if we do rendering with ribbons, we might be able to see this new helix that we've stuck in here. It's right here, and what we have to do is do some annealing. Let's select some residues here, and turn on the optimizer just for those residues. Let's do a small amount of optimization here just to begin with, so 100, or let's do more than that, 100 say cycles. If we look at this, it's going to only move these around because that's all we've selected, and obviously it didn't fit all that well, but in any event it's now going to anneal, and we probably want to do some more annealing even further here. Let's do a couple hundred and see what happens. The gradient isn't atrociously high, so there's the new splice in here. Still optimizing a bit. You obviously ought to optimize the whole protein, but what one can do in HyperChem is just select a portion and only optimize that portion. It's much faster, of course, than if you optimize the whole thing. Well, let's select everything here and show the selection only, or hide the selection rather, and see what we've got here. So this is the new piece. It's kind of contorted, and I'm not sure that that's terribly optimum, and that we probably ought to anneal much further here, but you can basically see the basic idea that we take any sequence in the existing protein and replace it by a new sequence of different length that may or may not fit very well when we first put it in. Depending on how much time we spend at it, we can find another sequence that will fit very well. The old sequence, we can measure the length and prepare a new one that's the same length, and so on. But that's the basic operation of replace.